ice is breaking up in the Antarctic Sea. The temperature has jumped out of the minus numbers, and at last, the sun is shining. It is early summer at the bottom of the world. The Adelie penguins have come ashore from the ice floes to play. Today, the first supply ships enter the Antarctic ice, 2,200 miles from New Zealand, the nearest civilization, and 11,000 miles from home. These ships were with us last year and the year before. Old-timers all to this Antarctic mission. Each year they return to the roost in McMurdo Sound to resupply our remote scientific station. Fuel oil makes up a large portion of the cargo brought by the ship. We've been shipping increasing quantities of oil to McMurdo each year. Fuel for all our Antarctic stations. Fuel for tractors and trucks and generators. Fuel for heating and for cooking fires. Now, for the first time, there is a change in this logistic pattern. Today, the Arneb unloads a 1,500-kilowatt nuclear power plant, the PM3A. This portable medium power plant introduces reactor power to the continent. It was developed and manufactured by the Martin Company's nuclear division, under contract to the United States Atomic Energy Commission for use by the Navy. It is an important link in the chain of Antarctic events, an integral part of the United States program for the development of Antarctica. Of course, anything you do in the Antarctic, including PM3A, must reckon with the intense cold and remoteness of the continent. Here the temperature drops to minus 60, and the night is 4 months long. Main base for this program is McMurdo Station on Ross Island, which is separated from the mainland by McMurdo Sound. The sound is frozen over during most of the year, and the ice forms Williams Field, the aerial port of entry for most of Antarctica. Even the Soviets on their way to their inland bases sometimes pass through Williams. McMurdo Station has its back to Observation Hill, where we will erect the nuclear power plant. The McMurdo area was first occupied by explorer Sir Robert Scott in 1910. This was his base camp, from which he mounted the assault on the pole that ended with his death. The present base was constructed between December 1955 and March 1956. It is the Antarctic headquarters for USARP, United States Antarctic Research Project, a joint effort of the United States Navy and the National Science Foundation. It is also field headquarters for Naval Support Forces Antarctica. The Navy performs the administrative and logistic functions on the continent. The National Science Foundation sponsors the work of some 200 scientists. What they learn in their studies of marine biology about the way of life led beneath the ice shelves may shed light on man's adaptability to outer space, or provide a new supply of food for future generations. Other scientists are studying weather conditions. There is no other place on Earth so cold or dry in the presence of so much water. Our plant will furnish electric power for these men. But to have it ready for them by the winter of 1963, we had to meet a rigid schedule. The PM3A plant was designed, fabricated, and tested in 14 months. so that it could be at McMurdo as early as possible for erection during the short construction season. The plant's reactor consists primarily of a pressure vessel containing the fuel core, source of the plant's power. Pressurized water flows through the reactor, cooling the thermal shields, then up through the core, absorbing heat generated by the fuel elements. This water circulates through the reactor and steam generator at 2,200 gallons per minute. The reactor generates nearly 32 million BTUs per hour. The heated primary water flows into the tube side of the steam generator, gives up its heat, and flows out. Secondary feed water is converted to saturated steam at a pressure of 300 psi. This steam drives the turbine generator, which generates electricity. Exhaust steam is condensed to water and recycled to the steam generator. To test the plant, the entire system was assembled in the factory 12 months after contract go-ahead. The erecting crew of Seabees, men of the Naval Construction Forces, studied the plant at the factory. In addition to these men, the Navy provides an operating crew who will test and operate the plant in the Antarctic. They receive specialized training for their jobs here, and with Martin engineers, they tested the entire system before shipment to make sure that it was functioning properly. First, the non-nuclear components were tested. A boiler from the decommissioned cruiser Hawaii substituted for the reactor by feeding steam directly to the turbine generator. The PM3A equipment generated electricity and cycled steam and water through the condensers and heat transfer apparatus. The nuclear fuel core was tested separately at zero power in the company's critical facility. In the core, there are 741 tubular fuel elements. Each has uranium-235 sandwiched between stainless steel cladding. Water fills the core and acts as a moderator, slowing down the neutrons so that they're able to split atoms continuously in a chain reaction. 90 boron rods of burnable poison are distributed throughout the core. They absorb some of the surplus neutrons released by the fission process, decreasing the excess reactivity of the core and reducing the number of control rods required. 6 movable Y-shaped rods control the reactor. These rods contain europium oxide stainless steel cladding. When the rods are fully inserted, a chain reaction cannot take place. We say that the reactor is subcritical. As all 6 are withdrawn, a point is reached at which the reaction is critical. A fission chain reaction takes place. The core went critical in a series of tests and responded properly to its controls. The package system, having passed its tests and ready for duty, was loaded aboard the USS Arnett at CB Center, Davisville, Rhode Island. The system is packaged into modules no larger than 30 feet long by 8 feet 8 inches square. The maximum weight of each module is 30,000 pounds. The Arnett carries not only the plant itself, but its fuel, 2 core loadings, fuel enough to last 4 years. The Arnett left the United States on November 3rd, less than 15 months after contract go-ahead. As winter approaches in the northern hemisphere, the Arnett starts its journey to Antarctic summer. She steamed south, covering 11,000 miles in 5 weeks. Simultaneously, the Navy operating crew, AEC representatives, and Martin engineers were airlifted to McMurdo. They joined the Seabees, who were already at work completing the foundation and buildings for the PM-3A site. The site had been selected and prepared a year earlier. It waited through the winter of 1961 for summer and the arrival of the Seabees. The Arneb was secured to the ice shelf at McMurdo Sound on December 13, 1961, and unloaded. The time available for unloading from the ship, for installation, and for initial checkout is limited to 2.5 months. The packages were moved on sleds from the ship, across the ice, and up Observation Hill to the PM-3A site. The Seabees will work 2 11-hour shifts to finish the job before the sun signals the onset of winter by dipping below the horizon. These vessels contain the reactor and the steam generator. These tanks provide auxiliary functions, spent fuel storage, radioactive waste concentration and storage, and increase of containment volume. Rock is crushed to make an earth shield around the tanks. Packed around the tanks, it forms an effective barrier to radiation. As work goes on, snow, another reminder that winter is never far off. Work must not stop, and inside, away from the weather, conditions are better. The turbine generator is installed in the center of the building. The switchgear distributes the power output of the generator through the nearby substation to the McMurdo base. Outside, we're installing the condensers, which receive the exhaust steam from the turbine. They are direct air-to-steam type, and they need no liquid coolant. Water flows out of them into the hot well. It is de-aerated and heated by the heat transfer equipment and returned to the steam generator for another cycle. The plant contains its own complete laboratory for analysis of system water and a control area for the decontamination of equipment and personnel. The months of December and January pass as the plant nears completion. Piping, wiring, alignment of equipment, and installation of firefighting gear occupy the last days of construction. The crew can begin the pre-critical testing of the plant. The plant is operated by a 3-man team per shift. From the console, one operator monitors and controls all of the nuclear, steam, and electrical systems. A second man checks and adjusts plant equipment. The third man is the shift supervisor. They've been trained for every conceivable situation: normal operation, health physics, maintenance, and emergencies. They use automatic instrumentation that continuously monitors approximately 100 points in the system: radiation, temperatures, pressures. Transistorized components ensure a high order of reliability in this instrumentation. The plant systems are protected by alarm lights and a horn. They warn that we are deviating from normal operating conditions and enable us to take corrective action. A separate precaution, the reactor safety system, automatically prevents the reactor from approaching unsafe conditions. It takes positive action, either holds the control rods or drives them into the core. The safety system is monitored by this self-test and display equipment. The crew training program has stressed safety, emergency procedures, and corrective action. February 22nd. The sun dipped below the horizon for the first time today. Winter is upon us. It is time for most of the summer support people to pull out, the Seabees who installed the plant among them. Wintering over personnel stay on. They now assemble the control rod actuators. After system checkout, the nuclear core is installed. Into the cold, clean core goes the radioactive source, the starter for the reactor. Now, for the first time at the site, we are working with nuclear fuel. We must monitor neutron count level as the core is lowered into the reactor vessel. Water within the reactor core serves to slow down the neutron, permitting limited fission to take place. But we know that this core is safe during the immersion process. We submerged it at the factory in tests, proving it would be well below criticality until the reactor is started intentionally. We are in the last lap in our race with the Antarctic winter. Time now to seal the tanks and start the reactor. The control rods are being withdrawn in slow, short, pre-calculated steps. At each step, as the rods are lifted out of the core, more uranium is exposed to neutron bombardment. We are reaching cautiously for an invisible condition in which the neutrons released by split atoms split other atoms in a continuous one-for-one chain reaction. This is a delicate but well-regulated job. Since this is the first time, we must creep up on criticality, the chain reaction. After this, we will have a more precise feel for the control. Scram! We were going too fast and the safety system put on the brakes. The rods are back in the core. We must start over again. Raise the rod. Wait. Raise them more. Wait. Wait. All eyes are on the log N recorder. This one seemingly insignificant instrument tells us when the chain reaction has begun, when the reactor has gone critical. The rods are withdrawn again. Again, we watch for the first signs of criticality on the log N recorder. The needle creeps over. The rods are coming out. The needle, it's positive. We're critical. The reactor is started. Subsequent starts will become routine. Now the exhaustive performance test program begins that will fill the months of winter darkness. The icebreaker East Wind waits offshore to pick up the last members of the summer support crew. The ice is reforming on McMurdo Sound, and the ship must leave. On March 4th, she battered her way out of the Sound. The east wind rolled and pitched through the screaming 60s, storm-racked seas between 60 and 70 degrees south latitude. scientists and Navy wintering over crews remain behind to carry on their job, as do Martin engineers, AEC representatives, and the Navy operating crew. They will conduct the performance tests and put the plant into operation. On July 13th, 1962, PM-3A began delivering full power to McMurdo Station. It brings warmth to laboratories and quarters. In winters to come, PM-3A will bring light for the long night. The plant will continue to deliver its 1,500 kilowatts for decades. It will operate on a single fuel core for 2 years of full power operation. PM-3A is the first nuclear power plant in the Antarctic. This peaceful use of atomic energy has shown the way for many others and will spread civilization in the world's remote areas. Antarctica will never be the same.